Well, good morning. It's time for an update on the foxbody Coyote project. And I think last update we were seeing this thing run and we were just dealing with a lot of other problems. But one of the things that I've learned, and you see the motors apart, I'll try to explain to you one of the problems that I'm having. So if you look at the program here, we are not in running state anymore. So one of the problems that I had is when I converted from Terminator X to Dominator. What's that about, you say? Well, this is Holley Terminator X, and this is the Dominator EFI. And this is the device responsible to control the variable cam timing on a Holley. And when you're using Terminator X, this device here, when the dip switches are set correctly, not only does the work of synchronizing things, it actually supplied the table, the values for where we want the cam timing to be. I wanted to be able to control that table myself, and I wanted a lot more inputs and outputs, and I had a Dominator ECU from a different project, so I had connected that up. And when using the Dominator ECU, we dip switch change in this one, and then we actually supply the table through software from a Dominator. And by having the cam timing table be adjustable, it's a better match for supercharging and for aftermarket cams that we have now. This table in here, the base table that's kind of programmed with it and stuck when you're using Terminator X, is better suited for closer to stock calibrations and stock camshafts. So I wanted more. But in the process, I discovered that I had a 20-degree cam error on the intake cam on bank 1. And I have some data I'll throw up on the screen here. But essentially, when the camshaft phasers, or the variable cam timing phasers, they're controlled through this electromagnet here. Power and ground go in, make this thing magnetic, make it reject this pin. Pin pushes out, and that pin acts on this pin in the middle here, and it varies an oil control orifice, which uses oil to push and pull on the variable cam timing vanes, basically. And this sprocket is not directly coupled to the camshaft. It goes through a variable vane setup in here. Regardless, when I had no pulse width, no power being supplied to any of these, when I was at minimum, you can see the data that I threw up, it was no power in. All the camshafts were resting at 0 degrees within a couple percent, except for this one. That one, as measured at the back where all the cam sensors go, that one is measuring, according to that data that we just put up, 20 degrees advanced. So I thought to myself, must have screwed up. 20 degrees sounds really close to what one tooth is on the chain. So I had checked that. It seems to be bang on. So then I thought, well, I screwed up in here because I took this apart already. There is small wedge blocks you put in there to limit the range of advance. If you have aftermarket cams that have more lift and you don't want to be able to ask the cam to move to a position that would allow the valve to smack the piston due to the increased lift. This combo has Gen 3 pistons with Coyote Gen 1 heads, which have smaller valves. So quite possibly it would never hit because the pistons have larger valve reliefs designed for a larger valve, but I have the Gen 1 heads on it still, so the valves aren't as big as the relief. So maybe I don't need it. But anyways, regardless, I took this apart. I had not put the wedge or limiter on the wrong side of the vane. I had to put it on the correct side, so that wasn't it. And the cam timing seems right at the sprocket. So either I'm not reading this correctly, there's a bug in the CAM's software, the CAM is ground incorrectly. I just don't know yet. So I'm going to do a compression check on right and left bank just to see if there's any difference. If there is a mechanical difference, then at least I know the camshaft timing is physically out and it's not a software bug. But it's odd for a software bug to generate a 20-degree error. So, but I have checked. I spent a couple hours last night comparing right and left, finding the marks in the back of that, and it just seemed like they're in the right spot. So that's where we're at right now. As far as the rest of the project goes, we did a fair amount of wiring work. I haven't recorded it because it's still really a mess and you can't tell that there's been a ton of work done. But we're getting to the point where we're close to being able to put the dash back in. And we also did some work on the dash to fit in. We have the Holley Pro Dash, the 12.3 inch Pro Dash, mocked up in here. And this is just laid out. But we took the back half of the stock cluster here and we marked it all out and did a little bit of cutting and hacking to grind it down. And we've attached the dash to the back half of the plastic, so now it just bolts in to the back half of the dash, and we got access to the GPS antenna. We got a couple USB-C inputs, and then we got the main plug here. And so that will bolt in like factory to the factory location. We'll lose a little bit in the middle of the hump here, in this area here, but not too bad. We'll see how we do with that. But overall, that's going to look pretty good, I think. We got a little bit of a gap in the corners here. Without any light behind them, it'll probably be fine. And that'll give us a pretty great programmable touchscreen dash that has all the bells and whistles. So that's pretty cool. And so we've got all the other systems wired into the, well, I can't see it now, but there's a fuse box under the seat. So all the vehicle systems, all the basics, like lights and horns and headlights, and we've actually got headlight relays now instead of just burning the switch out like these cars used to do, and all that kind of stuff. So although we're making big headway, we're taking things apart again. And yeah, so we'll see how this camshaft thing goes and update you on that later. So we pulled a few more things apart. Can't see it, but so I removed this. You can see I'm taking it off again because I don't know where else to look. And the way these things time, they have colored links, and the colored links point to the pointer here and down there. Anyways, I removed it, lined all the links up because they only line up once. Once you spin it over, it never really happens again for a long time. And it was in the right spot. I paint marked the camshafts before and after, or before I moved anything to prove that it was, whether it was right or wrong before I took it apart, and it's exactly the same position and it's timed correctly. So that chain was not installed incorrectly. It was this chain here is in the right spot. And because my camshaft sensor says he's in the right spot, the one at the back there, but it says he's off by 20 degrees, and I kind of can't look down here. These, that one, and that one all indicate very little error, less than 1 degree. That one, 20 degrees. So the options here are, the sensor's messed up somehow, but it just goes to the back of the block. What if this is on? What if this is pressed on wrong from the factory? Well, I guess that's possible. And then, what if the software is messed up, but because the Terminator X internal table and the external control table on the Dominator both indicate an error on that sensor, one using LEDs and one using nice clear data of 20 degrees, I kind of believe the software is okay. And because I just did my compression check, so I have that up there. Because I have, on average, a 208 psi cranking pressure on this side, and 185 or so on this side, that is logically in line with advanced camshaft timing on the intake cam, because the valve is closing earlier and trapping more pressure. So that does suggest that there is a mechanical problem on this side. So I don't know what it is. It's really weird. Maybe it's inside there. I don't know. Already looked in there. So I gotta take that off. I think I have another one of those. I might try putting it on and comparing the numbers that it generates. I don't know. It's definitely a stumper. These kind of jobs always are. I guess I could change the camshaft. I could put a stock cam back in. I have to prove whether the tooth wheel's on wrong on the back. That'd be really hard to prove. And if the tooth wheel was on wrong, it would just be like wrong in the sensor land. Be wrong on the digital side, not on the mechanical side. And the variance and compression suggests it's wrong on the mechanical side. Just for reference, because this is a Gen 3 bottom end, this is a 12.5:1 compression motor, so we are going to crank high. These numbers are pretty realistic at about 185. Over 200 isn't likely, just because the higher compression is going to crank a little less cranking pressure with a bigger camshaft. The bigger the cam, the sooner the valve opens, the less trap pressure we have, especially at a low cranking speed. 8,000 RPM, it's a different story. But anyhow, so still stumped, still thinking. Okay, I'm at that point in the problem solving process where I might be just talking to the camera because I got to hear myself think. So what I've done, we're still fighting this mystery of 20 degrees of cam timing error. Remove that cam phaser again, and I've been comparing it to parts from a core motor that I have, which is the motor I blew up, but the camshaft parts were fine. So here we have all three cam phasers, with this being the one off this current running motor and these off of the cores. And these are all intake cam phasers, which are different than the exhaust. But there's this mark here is my timing mark that has to line up with the colored link as it goes by. And that is indexed to that dot. So that pin right there interacts with the face of the camshaft right there. So right now, when there's no oil pressure being fed to these things, they are locked, and I have confirmed that they are all locked. They have a pin inside that falls in and locks them when there's no oil pressure. So they aren't just floppy around right now. They are in a position. I had one of them apart, and it's the max position that it's at 0 degrees or no advance. So I went and pulled the stock cam for this side because every cam is different in a Coyote. So the intake cam for the bank one, or passenger side, is unique to that task just by the way it's ground. And I'm trying to check the index of this to the lobes. And without like V-blocks and some dial indicators, and comparing it to a different duration cam, that is what's in here, I can't be 100% sure, but the basic orientation of this mark here to this tooth in the back is there doesn't seem to be a 20 degree error there. 20 degrees is enough that you can see with the eye. So I am, I don't know. Don't know what's going on. So I've double checked this point. This is probably 4 times. So that's what you would be wrong typically. Normally if I was off a tooth, it'd be about the error I'm looking at. I don't know for sure if it's 20 degrees. There's 28 teeth on this, but I'm pretty sure the error is being described in crankshaft degrees, not cam degrees. But regardless, I cannot formulate a good theory as to where I have a 20-degree error. And it's quite confusing. So this is just a scratching my head update. Some point, somehow, I mean, do I have to put that stock cam back in here and put it all back together and start the motor? And then how do I, if that's the issue, how do I prove it to comp cams? Oh, never mind the time, but how do I prove it right now in such a way that that's real? I mean, this point here and the lobes and the cam sensor teeth in the back all have to be agreeing on what spec it's going to be. The lobes can be moved around a bit depending on what the intention of the cam grinder is. It might be advanced or retarded a bit, changing the whole, hence a different cam profile. But the relationship of this to that should be exactly the same as a stock cam. And that's what I got to prove. So it probably means I got to pull the camshaft out, get them side by each on the bench, see what it looks like. All right, so here's the crazy thing. We took that camshaft out, and no big deal. Everything is tore apart right now anyways. And I don't have accurate enough specs or the know-how with this situation to really look at those and say what's different, what's not supposed to be different. But what I did is I think this wheel, which was the Traeger part, has to be the same for both parts. So I just used a solid block, and then just put the paper towel on it just to keep the crap off. But so it's sitting on this spot. There's one spot on the whole setup there that's really good and braced, and it's unique. It really puts it in one location. So that spot braces the camshaft. It really sits well there. The lobe doesn't even touch, so it's just the rotation right now is being controlled by the position of that wheel and that big gap between those two teeth. Now when you start comparing the two, and you look down, you're looking at just even the lobes, and the lobes are like, no, are not the same. But I'm like, well, I don't know what the lobes are supposed to be, but if you had to guess, if you consider this is rotating this way is rotation, these lobes are advanced over those lobes by a fair amount. And there's more duration in that. We can see the shape of it, but that is advanced. So then I'm like, well, how can I measure off the front of this? And you can't see it as obvious as I can probably, but I got some screenshots to put in here, but this one right here was like 24 degrees of angle, and this one is like 14. So very close to double the crankshaft. The error at the cam is twice at the crank, and that's how they're measured. So the cam is ground wrong. I can't see any other way to say this, but this camshaft is ground wrong. And now if you wanted to say, well, its camshaft is ground differently because it has a performance profile, I agree with you. But remember, this is not indexed or parked off of the lobes. It's off the sensor point at the back. And that's where my error is. So the sensor wheel, relative to the camshaft sprocket indexing points and bolts, has almost a 10-degree error. It can't be right. Especially when I'm looking for 20 degrees of crankshaft error. So, you can see it pretty from that angle, eh? I don't know for sure what to say here, except for this is really annoying.